Okay, so the third time. Okay, what we've done is we've laid the periodic table out based on the number of protons or the atomic number, okay? So it goes from left to right: hydrogen, helium, lithium, beryllium, boron, okay? So this is the first way the periodic table is set up. Now, every element wants to have its valence shell full, and it does this one of two ways. Either it donates electrons, okay, or it steals electrons. Donating means it's got extra electrons. Stealing means it's missing electrons. So is donating a positive thing or a negative thing? Positive. Is stealing positive thing or a negative thing? Negative, okay? So let's look at the yellow ones, the cream ones, are all the noble gases. These ones are what everything wants to look like, okay? Now, hydrogen, how many electrons does hydrogen have?
1.
How many electrons does helium have?
2.
So is it missing an electron or does it have an extra electron? Missing. Missing is -1. It has to steal 1. So it's going to be a -1. Think missing is negative. Extra ones are, you're going to donate them, that means it's positive, okay? All right, so lithium, helium. Helium has a full shell. It is neutral, okay? It is happy, it doesn't need to steal electrons, it does not need to give electrons away. Now lithium, okay? Lithium has how many electrons on its valence shell? 1. Is it going to want to think about giving away electrons? Costs $1 each. Stealing electrons costs $1 each. Okay? It costs the same amount to give away or steal. So the deal is you want to look like a noble the cheapest way you can. Okay? In these terms, we have 1 electron. Now this atom of lithium can give away an electron to look like helium. Everybody got that? Now, if it gives away an electron, how many negative electrons does it have?
0.
2. How many protons does it have?
3.
Electrons are negatives, protons are positives, so what is its overall charge? +1. So does that make sense how it has its charges? Okay, so if this one donates, it's going to look like this one. It's going to have its outer shell full, or this shell full, and it will be happy. Its charge will be a +1. Does that make sense to everybody? Now, beryllium, right here. Beryllium has 4 electrons. It has 2 in its first shell, but it's a valence shell. It has 2 valence electrons. Now, it has a choice to make. It can donate these 2. So it goes 1, 2. It looks like this. Or it can steal 1, 2, 3, 4, 5, 6. Okay? So this is going to cost $2 to give away. It's going to become a +2. This is going to cost $6. It's going to be a -6. Which one's cheaper?
$2.
$2. So what this is going to do is it's going to give away 2 electrons. You now have 2 electrons here, and you have 4 electrons here, or 4 protons. What's our overall charge?
2.
+2. That's right. So the other way you can think of it is you have to figure out how many steps it takes to go to this one. So 1, 2. So what I think about is I imagine I'm going across the river, and these are all stepping stones. And I'm standing on this one, and I want to get to that one. So how many steps do I have to take? 1, 2. Does that make sense? And I'm donating, so it is a positive or negative? +2. Okay? So, boron. Boron has 3 electrons. What is going to be easier? Donate 1, 2, 3 electrons, or steal 1, 2, 3, 4, 5 electrons. Donate 3. If it donates 3, then what's its charge going to be?
2 plus 2.
Plus 3. Okay, boys, stop. Plus 3. Carbon. Carbon has 4 electrons in its outer shell. All right, let's count it out. You've got 1, 2, 3, 4, or 1, 2, 3, 4. Could this one go positive?
Yeah.
Could it go negative? So this is called a plus or a minus 4. This one will go either way. This is nitrogen. Nitrogen has 2, 3, 4, 5 electrons in its second valence shell. It has 5 valence electrons. So let's count out how many steps it would be if we donate. 1, 2, 3, 4, 5. Versus 1, 2, 3. Which one's cheaper?
3.
Okay, so are we stealing electrons or are we donating them?
Still.
Stealing, is that negative or positive?
Negative.
Negative.
So it is a negative 3. See? Now, oxygen. Oxygen has 6 electrons on its valence shell, 6 valence electrons. So our options are to donate 1, 2, 3, 4, 5, 6. So that would be a positive 6, or it could go 1, 2. Which one's going to be cheaper? Donate or steal?
Steal.
2.
How many?
2.
So it is a negative 2. Think, how many electrons are missing? When we're talking about negatives, how many electrons are missing? This one's missing 2, so that's negative 2. If it's donating, it's extra. Think of positives. Okay, you've got positive 4. That's 4 extra. Okay, so the last one is fluorine. Fluorine has 7 electrons in its outer ring. Okay, so my option, let's try positives. Donating 1, 2, 3, 4, 5, 6, 7. So that would be a positive 7 or 1. Negative 1. Which one's easier?
Negative 1.
Negative 1.
Negative 1. Does that make sense? So let's go through these. Hydrogen is a negative 1. Helium, 0. Lithium, plus 1. Beryllium,
Plus 2.
plus 2. Boron, boys, plus 3. Carbon,
Plus or minus.
plus or minus 4. Nitrogen, minus 3. Oxygen, minus 2. Fluorine,
Minus
and then nitrogen, neon,
0.
0. Now, if I go to sodium, what's this one going to be?
Positive 1.
What's your thing around me?
Positive 1. Now we've just skipped to another noble. So now we've just changed. We were talking about helium to neon. Now we're talking neon to argon. So next, sodium is plus 1. How's about magnesium? What's magnesium going to be? Plus 2. Aluminum,
Plus 3.
plus 3. Silicon,
Even.
plus or minus 4. Phosphorus,
Minus 3.
minus 3. Good. Sulfur,
Minus 3.
chlorine,
Minus 1.
and argon, 0, neutral. Now, let's put these into the periodic table again. Grab them and let's go. Keep videoing. Keep videoing.
Like, can I go to the bathroom real quick? We're not leaving.
That's in the video.
Guys, we're not leaving. Hey, guys, come back here. Put him back in the periodic table.
Chaos.
Put them where they're supposed to be. Put them on there neatly. Okay. Now, do you see a pattern going on here? What is the charge of hydrogen?
1.
What kind of one? Positive or negative?
Negative.
Negative one. Because remember, it really should be over here. Boys, you're getting ready to take me off. Stop it. You think I'm going to tell you off in front of this? It should really be right here, right? But we keep it over here. Lithium is a
Positive.
positive what?
3.
1. Sodium is a
Positive.
how many? How many electrons are on this ring? Positive 1.
1.
What about this one?
Positive 2.
What about magnesium?
Positive 2.
Okay. What about boron?
Positive 3.
What about aluminum?
Positive
Okay. What about carbon? Plus or minus 4. What about silicon?
3. Plus 4.
Or
Minus.
minus 4. What about nitrogen?
5.
3 plus or minus. What about phosphorus? Plus or minus. That's very good. Oxygen? Very good. Sulfur? Minus 2. Fluorine? Chlorine?
Minus 1.
What pattern do we see? What about the columns? What's the columns tell us? They're all the same, aren't they? Other than hydrogen. Watch. Plus 1, plus 2, plus 3, plus or minus 4, minus 3, minus 2, minus 1, none. Does that make sense? Okay. The way I remember this is going up a hill and then down a hill. So watch. Plus 1, plus 2, plus 3, plus or minus 4, minus 3, minus 2, minus 1, 0. Plus or minus 4. Okay, everybody got this? Okay, so here's what you're going to do. You are going to go back and open up to page W210. You are going to put your charges on each element. Then you're going to go in and tell them the families on each element. So I need the charges and the families. Okay?
Dang.
Then I need you to submit that on 222 URL. Okay, submit it as a URL on 222. Now I know you're going to have to unsubmit your grade. For 210, do not resubmit it. Okay, I've already got a grade for it. I've graded everything. Do not resubmit. Does that make sense to everybody?
Wait, what are we submitting?
You are going to take your 210, you're going to grab the URL, and you are going to submit it as a URL under 222. Do not resubmit 210, because then that'll force me to regrade it, and I don't want to do that. I've already got a grade for it. Unless you fix it, and you want to submit it for a better grade. Everybody got that? grab these and let's go. Ma'am?
You're welcome.